5, problem number 27 reads, a stockroom worker pushes a box with a mass of 16.8 kilograms on a horizontal surface with a constant speed of 3.5 meters per second. The coefficient of kinetic friction between the box and the surface is 0.2. So part A, find what is the horizontal force the worker must apply to maintain this motion, 3.5 meters per second, constant. And B, if the force calculated in part A is removed, how far does the box slide before coming to a rest? So, draw some diagram here. I don't really need it too much, but if that helps you, then it helps you. But since we have a constant velocity, our acceleration is 0, means the net force is immediately 0. Our y doesn't matter too much here. So force of friction is equal to force normal times the mu. Force normal is going to equal gravity, which is mg. And our force of the worker is going to equal the force of friction. So the main force is going to equal mu times mass times gravity. Gave us the numbers, plug those into a calculator. The force the worker applies is about 32.96 newtons. Part B, that force is now removed. So we use F equals ma, and our only force in this instance that has acceleration is friction. So friction equals mu mg, as we figured out earlier. So divide the mass on both sides. Acceleration in the x direction is going to be equal to mu times the acceleration of gravity. So throw in our kinematics equations. Initial velocity is 3.5 meters per second. Final velocity is going to be 0. Acceleration is going to be negative mu g. And we're looking for our displacement, which will be a positive number. And we don't need time, so we use this equation, v squared equals v naught squared plus 2ad. Rearrange it algebraically, so negative v naught squared, the negative's outside of the square, divided by 2a is going to equal d. So negative 3.5 squared over negative 2 times 0.2 times 9.81 will equal our distance. The negatives cancel out, and the box will slide 3.12 meters before coming to a stop. Where's the button?